Okay, in this video we're going to talk about adding and subtracting rational expressions. Rational expressions are a fancy term for fractions. When I say fractions, people tend to think of 2/3, not 5x minus 2 over x plus 3. So rational expressions is a broader term. Some of the terminology I'm going to use in this video, we're going to talk about prime, relatively prime. We're also going to talk about the distributive property, and then the concept of an LCD. So I urge you to review these four terms. Um, I'm guessing that relatively prime is the tougher one, toughest one here. To be relatively prime, for a set of numbers to be relatively prime, they can share no factors. So for example, 3 and 11, that pair of numbers is relatively prime. I should write it like this, because they share no factors. That's going to be true for any set of numbers. If there's two numbers, I should say, if one of them is prime, then the pair is going to be relatively prime. But another pair in which has no prime numbers would be something like, 4 and 15. 4 and 15 share no factors. The factors of 4 are 1, 2, and 4. The factors of 15 are 1, 3, 5, and 15. I guess they share the factor 1, but that's the only one that's possible to be shared. Outside of 1, if they don't share any factors, then the pair is relatively prime. So I want to be able to use the terms prime, relatively prime, distributive property, and LCD. So be prepared for that. Okay, so to think about the addition of and subtraction of fractions, I'd like to be able just to consider addition. We'll talk about this subtraction a little later, but for now, whenever I write the plus sign, consider it to be equivalent to the minus sign if I'm adding the opposite of a fraction. So if I add 1/2 plus 5/8, I'm hoping you recognize pretty quickly the LCD here is 8. Notice that these two numbers are not relatively prime, and you can always get a common denominator by multiplying the denominators together, but if they are not relatively prime, then the product of them will not be the LCD. Okay, so the LCD here is 8, and we're going to get 4/8, which is equivalent to 1/2, plus 5/8, and you're going to get 9/8. Okay, if I do 1/2 plus 4/7, this pair of denominators is relatively prime, namely because both numbers are prime. And so in order to get the common denominator, we just multiply the two. I'm not going to have to worry about any shared factors being redundant. So 14 is the common denominator. We're going to get 7/14 plus 8/14. I'm going to get 15/14. Okay, let's skip to one in which a pair that is not relatively prime. Much like 2 and 8, but in this case, 1/4 plus 5/6. Well, these numbers are not relatively prime. They share the factor of 2, which means that their product is going to be twice the size that it needs to be. The product of the factor of 2, if I had to multiply the 4 and the 6 together, is going to be repeated. So I could multiply them together to get 24, recognizing that there's a redundant 2, which makes the denominator 12, or I could just eyeball it and see that the least common denominator is 12. I'm going to get 3/12 plus 10/12, and that's going to be 13/12. Okay, odd that I picked 3 examples which the numerator is 1 greater than the denominator. That was not intentional. Okay, so to reiterate, I could put a subtraction sign in here, and a subtraction sign here, and a subtraction sign here, and the rules work the same. I mean, obviously I get different answers. I would get negative 1/8 here. I would get negative 1/14 here, and I would get negative 7/12 here. So the rules apply the same for subtraction as they do for addition in these particular cases, but finding the LCD is the same. Okay, so let's move on to something a little bit more difficult, more difficult rational expression. If I did x over 4 plus 3x minus 7 over 6, notice that this is very similar to the problem right here. Instead of having a numerator 1 and a numerator 5, I have a numerator that involves a variable. To the mathematician, these two problems are essentially the same. For this algebra student, this is like a, 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 a quantum leap in difficulty because it involves a variable. But if you're comfortable with variables, then this process is the same. Maybe you'll take an extra step that looks something like this. Recognize that when we change a fraction to its form that is a common denominator 12, okay, I have to multiply the fraction by a form of 1 so that it's so that the fraction's value doesn't change. So in order to multiply by 1, I have to multiply by a fraction whose numerator and denominator are the same. So if I want to change the denominator by a factor of 3, I have to have a numerator of 3 also. So these two guys get multiplied. So x times 3 is 3x, and 4 times 3 is 12. And this guy, to get to a denominator of 12, I'm going to multiply the denominator by 2. So I have to have a numerator of 2 also, so that the value of the fraction doesn't change because I'm multiplying it by 1. And then here's where the distributive property comes in. I'm multiplying 2 times 3x minus 7. And I have to include those parentheses. And then I put a plus sign here. And notice that the plus sign could be a minus sign, and everything would be the same to this point. I just would have a little bit different arithmetic at the end. So 3x over 12, a lot of kids reduce that to x over 4, forgetting the fact that they want the denominator to be 12, because that was the whole point of making a common denominator. So I can now call this 3x, and I can call this 6x minus 14. And here I get 9x minus 14 over 12. Okay, so that's a good example where we have to use a common denominator for rational expressions. The point here, though, is that the process that I did just here, maybe a little bit more intuitively up here, is the same as the process here. I just wrote a couple of extra steps to make sure we were multiplying by 1. Okay, so let's raise it up a notch. Let's do 10 over x plus 1 minus 5 over x. Okay, so I've got a minus sign in here. That's the first thing to be alerted by. And then I've got denominators now that are variable quantities. The patterns don't change. The processes don't change. You're still asking yourself, do these denominators share any factors, or are they relatively prime? The answer is no, they don't share factors. So therefore, they're relatively prime, and their product is going to be the LCD. Okay, so the LCD here is x times x plus 1. Okay, so what do I multiply by to get the denominator x times x plus 1? Well, I have to multiply x over x. Remember, I have to be multiplying by 1. And this one, I'm going to be multiplying x plus 1 over x plus 1. That way I'll get the denominator that I desire. Okay, so I'm multiplying these two. I don't like putting a line there. I'm just going to put an equal sign. We're going to say this is 10x over x times x plus 1 minus 5, and here comes that distributive property again, 5 times x plus 1 over x times x plus 1. Now remember, we're not trying to simplify and divide right now because the whole point was to generate that denominator. Okay, so now I can say the common denominator is x times x plus 1, and my numerator is 10x minus 5x plus 5. There's that distributive property coming, and here I have 5x plus 5 over x times x plus 1. That's an acceptable answer. Teachers typically want you to do it completely factored or completely unfactored, just to make sure there aren't any common factors. I'll factor out this 5. Did I make a mistake? I sure did. This should be a minus 5. There's that distributive property getting messed up. Okay, this is 5 times x minus 1 over x times x plus 1. And you can see now that the overall fraction does not have any common factors. The mistake I made there was this minus sign applies to the subtraction of minus this quantity, and when I distribute that negative 5 across the x plus 1, it's minus 5x minus 5, not plus 5. My bad. Okay, so I just want to make a general argument here. If you see a over b plus or minus c over d, okay, the LCD is going to be the product of the denominators if the denominators are relatively prime. So let's just assume that for the moment. So I'm going to multiply a over b times d over d. And I'm going to multiply c over d times b over b to achieve the LCD of BD. Okay, so I get the common denominator of BD, and I get AD plus or minus BC. That's going to be the form of the addition and subtraction of rational expressions all the time. Now, if B and D are not relatively prime, then the LCD is going to be something less than BD, and it's going to involve removing the redundant factor. This will still work. You may have some fraction reducing to do at the end of your problem. So, for example, sometimes at this phase, there's a little bit more simplification to do if you haven't found the LCD. Sometimes there's simplification to do even if you have found the LCD, so that's something to be careful of. Okay, last one. One more degree of difficulty. X plus 1 over x squared minus 3x minus 4 minus x times x plus 4 over x squared plus 10x plus 24. Okay, this is a pretty gnarly rational expression or subtraction of rational expressions. I think the key here is to recognize that maybe there's some simplification to do in each fraction prior to figuring out the LCD, because it looks like the LCD of these two might be their product if they don't share any factors. So let's just check out the factorization. X plus 1 over, now the denominator factors, I believe, into x minus 4 times x plus 1 minus x times x plus 4 over, this one I believe factors into x plus 6 times x plus 4. Okay, now we notice that these two denominators don't share factors, and it looks like their LCD might be their product, which would be a product of 4 linear factors, and that would be pretty gnarly. But you also realize that there's a common factor in the numerator and the denominator of these fractions, and anytime there's a common factor in the numerator and denominator, you may divide them. I don't use the word cancel, I use the word divide because that's what you're really doing. You're dividing these factors. So then our expression turns into something much simpler. 1 over x minus 4 minus x over x plus 6. And then we're back to the degree of difficulty we had just above. But let's finish this guy. Are these two denominators relatively prime? Yes, they share no factors. So the denominator is going to be their product. So what do I need to multiply 1 over x minus 4 by to achieve the LCD of x minus 4 times x plus 6? Well, I need to multiply it by x plus 6 over x plus 6. And then I have this one, x over x plus 6, which I must multiply by x minus 4 over x minus 4. And so we're left with x plus 6 over, I guess I'll just do the entire common denominator now. This is x minus 4 times x plus 6. And then minus x times x minus 4. over that same denominator. And what's left is just the algebra up here of combining like terms. X plus 6 minus x squared plus 4x with the distributive property. This is still over x minus 4 times x plus 6. And this is equal to the opposite of x squared. I have like terms x plus 4x, so plus 5x. And then I have plus 6 all over x minus 4 times x plus 6. And I'm wondering if I can factor the numerator now. Maybe there's a common factor in the numerator and denominator still. So what I'm going to do is take the opposite of the numerator. I'm going to call that the opposite of x squared minus 5x minus 6 all over x minus 4 x plus 6. Does that numerator factor? X minus 5x minus 6. I believe it does. I believe it factors into the opposite of x minus 6 x plus 1 all over x minus 4 times x plus 6. Okay, are there any common factors in the numerator and denominator that I may divide? X minus 6 and x plus 6 are not the same, nor is the opposite of x minus 6 equal to x plus 6. So the answer to that question is no. There are no common factors, and that's as simple factored form as I can get. And when you study rational functions, you'll know what the graph of this function will look like, but that's not the role of this video here. This is just to practice your addition and subtraction of rational expressions. I hope that helps.